All right, here we are at the final part of Precision, Part 13. Logan, I'd have to say Part 12 went quite smoothly, if you ask me.
Right, no major hiccups and everything in it just worked.
Yeah, too bad it's not always like that. Everything should always just work. But when coding, it doesn't always work out like that. So now, Part 13, this is where we're going to wrap everything up nice and neat. We're going to take that power-up class that we created, we're going to extend it into the time power-up, and then with that, we need to set up some sort of system in which we can slow time down, and then we need to make the time power-up responsible for activating that system, if you will. So we're going to really divide this up into two sections, which is you can kind of look at, here's the game as we have it now. And then really the power-up and all is just something outside of that. We need the game to be able to be slowed down. And then what we can do is we can add on this time power-up, and the time power-up can trigger that slow down. Okay? So inside of the time power-up, we're not going to find any type of complex code in our activate or deactivate methods. Really, it's just going to be setting a very simple field back over in Actor. So
right, it's almost like the game speed has to be implemented as a feature going all the way back to Actor.
Exactly. So that is the objective. Let's take a quick look at what all we need to do to accomplish this. So here we go. We'll pull this up, hide this out real quick, jump to the top, and bring in a new whiteboard. All right. So our final part, 13, the lucky number. Time power-up. All right, so this is going to be divided up into two sections. The first section is implementing the time control inside of Actor, okay? Actually, it's inside of Actor, it's inside of Enemy, and it's inside of Cell. But we're going to get the heart of it inside of the Actor class, our field that's going to allow us to control scaling time, because that's basically what we need to be able to do. So we're going to start out in the Actor class. And inside the Actor class, we are going to create a new field. And this field is going to be a static float, and it's going to be called time scale. It's static because we're going to need to be able to reach it from outside of Actor. And we don't want a bunch of time scales. We only need one time scale.
Right. Since the idea is that this is the time scale for everything. Everything that is Actor derived should be set up to respect this value. And therefore, much like with, I'm trying to think of another good example for static. I guess you could say with the list. The list of actors was stored in Actor, but it was static. So it was at that point, the Actor just becomes a convenient place, an organized place to put this field.
And we're also going to start this guy off initialized at a value of 1. Because at a value of 1, everything is going to be at normal time, regular time, okay? So once we have this field set up, we're going to turn right around and create a property that will allow us to set it. And of course, that property is also going to be a static float called timescale. All right, so now that we have these two members set up, we can turn around and use them to control everything that moves. Basically, we need to affect everything that moves in such a way that it's going to slow down. And there's 3 areas that we need to hit. In Actor, where we've got scaling taking place. In Enemy, where we've got enemy movement taking place. And in Cell, where we've got that cell dying code set up. So let's go ahead and here's our main areas. Actually, let me do it this way. This will be a little nicer. Actor. Inside of Actor, we need to affect the update. In fact, they're all going to be the update methods. And what we need to do is affect the scale calculation and the scale time calculation. If we were to take these two calculations and simply multiply the result of it by time scale, what we're going to do is get a smaller number. We're going to make scales go, scale's going to scale slower, and it's going to take longer to scale down.
And in that case, we have to affect both the scale and the scale time, where scale there represents that scale per second. And if we multiply both of them, then we'll keep the overall time and the resulting scale in sync by the end and adjust only the time. So if we take the scale per second and make that less by multiplying it by time scale, we also need to take the scale time and make that decrement more slowly. So that way we have smaller amounts adjusted per update, and then we also take more amount of time for the update to complete.
Exactly. Now, in enemy, what we need to do is affect the move speed. So with that, remember the amount, which was that field that we were using in smooth step to control us moving from point A to point B. We need to simply take the calculation that's coming up with the amount and at the end tack on multiplied by timescale.
Right, because amount is advanced very slowly, fraction by fraction, through each update, moving from 0 to 1. So if we take each of those updates and then multiply them by timescale, that gives us the ability to adjust how much the amount is affected per update.
Okay, then we need to turn our attention over to cell. And inside of the cell class, in update once again. Now, of course, cells die, and cells die based off of a life percent. That's what's controlling how much time they have left to live. So we'll just simply take that life percent and we'll multiply that calculation by timescale.
And then really the same idea. Since life percent is decremented by a small fraction each update, we take the overall amount that's going to be taken away from the life percent and just multiply that by time scale. And that, once again, gives us the ability to control how fast life percent is decremented.
And at this point, we're ready to test. So we can just go ahead and come in here and we can do a test after we make a setting to the timescale of something other than 1. So we can test it right now, make sure everything runs at normal speed and that we haven't messed anything up, and then we can turn around and inside of begin level, just as a real quick temporary test, we can dump in there actor.timescale equals and something like 0.3. And then test the game again, run it again, and what's going to happen is everything, because we've multiplied everything that moves in all of our updates by that timescale, everything is going to slow down because we're now multiplying by 0.3, so we're going to get a much smaller number. So that's going to result in everything looking as if it's been slowed down. Then we can turn around and we can take timescale and turn it up to like 2, 3, 5, 10. We can speed the game up as well and show you what that would look like. So it's a lot of fun playing with timescale. And once we have verified that this works, basically what this will do is this will wrap up the system in which we can control time in our game. Then we can turn around and start focusing on this new class that we need to get in place, which is our time power-up. So we'll begin here by creating the new class. So our time power-up. And time power-up is, of course, going to extend power-up as we talked about in the last part. And then we need to remove out the usings we don't need, add in the XNA framework. You guys know what we need to do. And from there, then we can go ahead and focus on making it work. And in order to do that, we're going to set up a field back over in the game class that is going to contain what the time power-up slowdown speed should be. So then if you want to make some tweaks to it, then you can simply go back to this one location, change this one number, and test again. So let me just jot down real quick. Now that we have our class, let's say over in the game class, we are going to create a field that is going to be a constant. So a constant float called time power-up slowdown. And we're going to set this to 0.1. Okay? This is going to be the number that we're going to set our time scale to inside of the time power-up. So inside of time power-up, we're basically going to say, look, actor.timescale, when we call activate, equals time power up slowdown. So we're going to be setting our time scale to 0.1. It's going to slow everything down. Okay, so once we have that done, now let's go ahead and shift our attention back over to our new time power up class. And back over in the time power up class, first thing we need to do is create a field. Our field is going to be our slowdown percent. And we're going to make a property for it. And once again, slowdown percent.
And this is, of course, just so that the time power-up itself can remember what the slowdown rate is supposed to be, so that as the gameplay continues, if it respawns several times, it still remembers what the slowdown percent is going to be if it's activated.
Exactly. Basically the same thing we did in the last part, where we were holding that active time and the respawn time.
Right.
So our methods, we've got a constructor. And basically, the constructor is going to be empty, but we have to have it because we've got a texture that we've got to pass all the way back up to actor, and a time bar color that needs to be passed back up to our power-up class. So constructor. Now we've got those two methods that we created in the power-up class, the two protected virtual methods, activate and deactivate, and we need to use those here for actually kicking off this entire slowdown thing. So we'll go ahead and implement those. So those are, in fact, I'm not even going to write all that. So those are the protected, but there what we're going to do is protected override, activate, and override deactivate. Now, the code that's going to go in them is going to be really simple. When we call on activate, all we need to do is take actor dot timescale and set it to. Now, a second ago I said we're going to basically set it to the time power up slowdown, which we are, but we're going to do it indirectly because, as Logan says, we're going to need to remember that number. And the way we're going to go about doing that is by taking that number and putting that into our slowdown percent, which is a local field. So we'll just turn around and say slow down percent. And then when our power up runs out of time and deactivate gets called, all we need to do is set the time scale back to 1. So we'll just simply set that back to 1, and everything will resume back at normal speed. Okay? So once we have this in place, there's just a few more things that we need to do. And let's see if I can find a decent area to write without creating a new screen. So let's just say we come right back up here. We're going to jump over to our game class. So in game class. We need to go ahead and change power up to time power up, because remember in the last part when we were testing the power up class, we had created that time power up, which was of type power up. We need to go ahead and change that. So let's go ahead and make a note to do that.
Right, we need to look at it as an actual time power up. Most importantly in the creation, so that we create a time power up and not just a generic power up.
Right.
And then after that we'll need the reference to be of that type so that we can get to the slowdown percent property.
Okay, and then what we need to do is add in a little bit of code. We need to go ahead and tell this time power up that its slowdown percent, as Logan just mentioned, is equal to the time power up slowdown, which is what I just mentioned a second ago. So let's go ahead and jot that all down. So we're just going to add in time power up dot slowdown percent equals, And what is it going to be equal to? It's going to be equal to that guy that we created back over in the game class right here. So I'm going to abbreviate that. Time, power up, slow down. So time, power up, slow down, TPS. There you go. And that is what slowdown percent. So now you can see where we've linked it all up now. So now when we call upon activate, and inside of activate in the time power up class, when we say actor dot timescale equals, and then we send over the slowdown percent, we're actually sending over the value that was being held in the time power up slowdown. Okay? So we'll go ahead and get that set up. And then we've got a bug in there that's very interesting that we'll see if Logan can show you, which is basically as we change through levels. So we'll have to make sure we put that level changing code back in. If we're right in the middle of a slowdown, so the power-up's active, and we've still got a little bit of time on the bar left, but the last savable cell just went away. What happens? We go through a level change, but we're still in the middle of an active power-up state, meaning that time scale is not at a value of 1, it's still at 0.1. So when we start the new level, everything is still very slow. So we need to fix that bug. So I'm just going to say fix bug, dealing with level changes. And then after that, we just need to make sure that we set our actor.timescale back to a value of 1 and begin level at the very top, which is going to make sure everything's nice and cleaned out. That is our fix, actually. And that's it. That will wrap everything up. So in essence, in this section, the heart of everything really lies right over here in setting up these two guys, our timescale field and our timescale property, and then turning around and using them to control our animated actors by adjusting the scale and scale time, by adjusting the amount in the enemy movement, and by adjusting life percent inside of cell. And by doing that, and then simply adjusting the actor's timescale, update takes care of the rest. Everything slows down. Then we just simply come in with the time power up class and hook it up so that it is what is changing the actor's time scale when it gets activated and deactivated. And that's pretty much it. Is there anything you want to add to this, Logan?
I can't think of anything. This covered the two major stages, that, if you want to call them that, where we set up the timescale feature of actor and subsequent actors, and then setting up the time power up to utilize that.
Okay. So with that, that's going to wrap up this video. Next video, we will code it. Thanks a lot.